In this video, we're going to look at question 4 of CAPE 2024 Pure Maths, Unit 1. Part A reads, a plane P passes through the point 5, 1, minus 3, and is perpendicular to the vector n, which is 3i minus 4j plus 2k. And we're asked to find the equation of the plane. So the first thing that we should do is basically, we just have to recall what the formula for the equation of the plane is. And let's say the normal vector is ai plus bj plus ck, and the passes through the point x0, y0, z0, then the equation of the plane is a times x minus x0 plus b times y minus y0 plus c times z minus z0 equals 0. So for our question here, a is equal to 3, b is equal to minus 4, and c is equal to 2. That's the normal vector. And then x0 is equal to 5, y0 is equal to 1, and z0 is equal to minus 3. That's the point it's passing through. So if I just put all these things into my equation becomes 3 times x minus 5 minus 4 times y minus 1 plus 2 times z plus 3 equals 0. Now if I just expand, 3x minus 15 minus 4y plus 4 plus 2z plus 6 equals 0, or 3x minus 4y plus 2z, and then the last term is minus 5 equals 0, and that's the same thing that they asked us to show. Now we're asked to find the angle in radians between this plane and the plane with equation 7x minus 4y plus 3z is equal to 5. When we're asked to find the angle between two planes, all you really need is the normal vector. So for our first plane, we know that our normal vector, let's call it n1, is equal to 3 minus 4, 2, right? I mean, this was given in the question, but you can also see it just by looking at the coefficient of x, and then the coefficient of y and the coefficient of z. Similarly, for this plane, the second plane, the normal vector is going to be 7 minus 4 and 3. It's just reading off what the coefficient of x, y, and z are respectively. To find the angle between the two planes, now we have to find the angle between these two vectors. And the way that we have to do that is using the formula cosine theta is the dot product of the two vectors over the product of their absolute values. So just to remind you what the dot product of two vectors is, I just take the x's and I multiply them together, then I add the y's multiplied together, and then I add the z's multiplied together, and then all over. Now to find the absolute value, what I have to do is I have to take the square root of everything squared, the sum of all the squares. So for example, n1, which is 3 minus 4 and 2, it's the square root of 3 squared plus minus 4 squared plus 2 squared, and then similarly for n2, it's going to be square root of 7 squared plus minus 4 squared plus 3 squared. Just when you're doing this, make sure that the minus is inside the square, because it'll change your answer if it's outside the square, right? So now if you do this and plug it all into your calculator, what will you get? You're going to get 21 here plus 16 plus 6 all over square root of 29 times square root of 74. Now when you put this into your calculator, you're going to get this is equal to 0.928. Then, but this is cosine theta, so what's the actual value of theta? Keep in mind that your angle, they said it has to be in radians, so theta is equal to cos inverse of 0.928, which is about 0.381, right? So that's how you'd find the angle. And always keep in mind what they're asking you, what units they're asking you for, because they could equally ask you if it in degrees, and then you have to find the angle in degrees. Okay, let's move on now to part B. That says the equation of a circle is given as x squared plus y squared minus 6x minus 8y minus 39 is equal to 0, and we're asked to find the center and the radius of the circle. Now, there's a formula that you can just memorize if you need to, but I always find it easier to just complete the square on both sides. So let me just show you what that is like. What I'm going to do is I'm going to take this equation, and the first thing is I'm going to put the x terms together, and then the y terms together, and then I bring the 39 on the other side. So x squared minus 6x plus y squared minus 8y is equal to 39. Now I'm going to complete the square for both the x and the y term. So to do that, what I have to do is I have to take the 6 divided by 2 and add the square of it, so plus 3 squared. Similarly here, y squared minus 8y, take the 8, divide by 2, it's 4, so then plus 4 squared. And now to keep the equality, I have to add that same thing. So I added a 3 squared and I also added a 4 squared, like this. And now this here is going to be equal to x minus 3 all squared. And then similarly, this is equal to y minus 4 all squared. If I add all of these things together, I get 64. And from this form, I can tell what the center of the circle is. The center of the circle is 3, 4. That's just like the x coordinate will be what's x minus, and then the y coordinate will be what it is, like y minus. And then the radius, it's always the square root of what's on the right hand side. So it's the square root of 64, which is just 8. Let's move on to part 2 now. It says find the equation of the tangent to the circle at the point 11, 4. When we're asked to find the equation of the tangent, the first thing that we should do is find the gradient of the radius. Well, the radius passes through 11, 4, because that's the point, and the radius also passes through the center. So it also passes through 3, 4. So these are the 2 points. So therefore, the gradient is y2 minus y1, which is 4 minus 4, all over 11 minus 3, which is just 0. This means that the radius is a horizontal line. And since the tangent is perpendicular to the radius, this means that the tangent is a vertical line. So the equation of the tangent is just going to be x is equal to a constant. And since it passes through the point 11, 4, the equation of the tangent simply has to be x is equal to 11. Let's now do part C. Part C reads, a point Q moves in the xy plane such that it is equidistant from A, which is 2, minus 5, and B, which is minus 2, 3. Find the locus of Q. Basically, this comes down to translating in terms of equations what it said in English there, that is equidistant from A and B. So let's say that Q is x and y. What's the distance from Q to A? Well, that's going to be, this is by Pythagoras' formula, x minus 2 squared plus y plus 5 squared. Now the distance, similarly, I'm just going to find what's the distance from Q to B. That's going to be the square root of x plus 2 squared plus y minus 3 squared. And because it's equidistant, these two things have to be equal. So I can equate these two things and then cancel the square roots. So I got x minus 2 squared plus y plus 5 squared equals x plus 2 squared plus y minus 3 squared. Now I'm going to expand all of these brackets. So I have x squared minus 4x plus 4 plus y squared plus 10y plus 25 equals x squared plus 4x plus 4 plus y squared minus 6y plus 9. The x squared terms will cancel, the y squared terms will cancel. And now I'm going to group everything by bringing all the y's to the left-hand side and then everything else to the right-hand side. So the left-hand side is just 16y. The right-hand side is going to be 8x. And then if I look at all the constant terms, I'm just going to get minus 16. So then I divide by 16, and I get that y is equal to x over 2 minus 1. And that's the equation of the locus. Whenever, just for your information, if it's the locus of the points which are equidistant from two different points, the equation is always going to end up being a line.